All right. So welcome back. How's everyone doing today? All right. We'll start class out with any questions that you may have. We have a test on Thursday, right? So I do have what some students would consider a review, but I'm not a big fan of reviews because when I give you a review, for some reason, students think that this is what the test is going to be, and I'm just going to change things around a little bit. And so then when they get the test, they get all upset because they're like, well, it was nothing like the review. So I'm not calling this a review. I'm calling this more of like a recap of topics. I'm not married to this thing in the sense that I have to give you a test that is exactly like this, all right? To be prepared for this test, you need to have done your homework, kept up with the lectures, made sure you're understanding all the questions I'm doing in class, practice, and we'll see, right? I'm going to try and make a fair test, all right? I also said I would check your homework today, right, as a quiz grade. I also said I would check that you have your formula sheet. Remember this? I remember.
It was either or.
Is one or the other? So let's start with questions. Are there any questions over any of the problems? Anything that I've done up to this point or anything that you want to talk about? No? Do you all feel ready for this test? Okay, so you want to talk about that? It was 31?
31 on
and 6-1, number 31.
So do you have any additional material to teach today, or is it going to be?
Well, there's nothing that's going to be on the test. Nothing I would do today would be on the test. What I really was hoping we would do is kind of like break out into groups, and then you would start looking at this practice thing that's not a review for the test. And so you kind of get an idea of the scope of what's covered. Because we go all the way back to Chapter 3, Section 5. We go all the way back to that. So I was going to give you maybe the first half hour, 45 minutes to go over this. Or you work through it together. And then maybe spend the last 45 minutes or so with me answering any questions that you ran into on this. So if it's something you look at, you're like, yeah, I got that, no problem, then go to the ones that are more challenging, try and get those done. That's my plan. All right, but I'm being asked about number 31, which was a kind of a bonus sort of issue, problem, yeah?
The 6.1.
This is 6.1 homework. Okay, use reduction formula. So it's saying to use a reduction formula from example 6 in the book to show that this integral is this. So use the reduction formula from example 6. So if you flip back to example 6, is the reduction formula. And we actually did that in class, didn't we? So using the formula, do I need to write the formula out on the board again? It's right here on page 315. It's formula number 7. So according to the formula, if this is an n, if our n right here is 2, then the formula says what? Negative 1 over n, so we would have what? Right, hold on. Negative 1 over n. So for us it would be negative 1 over 2. And then the formula says cosine x sine to the n minus 1. So what would that be? Sine, just sine to the first power, plus n minus 1, which would be 1 over, you did it as a bonus. Anyone else do it as a bonus that want to turn it in? Where else? Now, integral sine to the n minus 2. What would n minus 2 be here? 0? Now, what is sine to the 0 power? 1. So this is really just a 1, right? Anything to the 0 is 1. Well, except 0 to the 0, but that's a different scenario. So this right here, this whole thing should be a 1, which means what is the integral of 1 dx? Just x. Just x, right? So this becomes negative 1/2 cosine x sine x plus 1/2. We said the antiderivative of 1 with respect to x was x plus some constant. And I'm trying to get it to look like this, right? Do we agree? So how am I going to do that? Do I have this already? Right? That's this, right? So all I need to show is that this is equal to this. Are these two the same thing? Okay, there would be if there was a 2 in front of this. So let me write that down right up here. Negative 1/2 is sitting out there. You said that this right here, if it had a 2 in front of it, it would be sine 2x, wouldn't it? So I'm going to put a 2 in front of it. Can I rearrange it? Sine x, cosine x, is that all right? But I can't just put a 2 in front of it, right? What else would I have to do if I put a 2 here? I'd have to put a 1/2 in front of that. Isn't that the same? Isn't half of 2 1? And so I haven't really changed the problem. But what's this right here? Double angle, that's sine 2x. And then what's this right here? Negative 1/4. And so that's this, isn't it? So it is the same thing. Did you get it to this point?
I got it to that point, and it was just like, I don't know, I struggled on that, so I was like, well, maybe I can change the integral sign into like the 1 minus cosine, all that stuff.
Yeah.
Over 2, and I was like, that's not.
They just wanted a direct replacement. You could have maybe done this and said, hey, look, I know that this is what? 2 sine x cosine x. And then the 2 in this would be that. And that matched exactly what you had here. So anytime you see sine x, cosine x next to each other, be thinking double angle.
It's one of those hidden ones.
It's kind of like a hidden one a little bit there. All right, that was part A. Do I need to talk about B, or is part B to prove it?
Part B was like basically taking the same thing, but with the sign to the fourth.
Okay, so
Yeah, that was okay.
that one was all right?
Yeah, number 2,
Okay.
or sign to whatever. Don't worry about that.
Anything else? Yes.
Question number 13 from the homework.
13. Question 13. E to the 2 theta sine 3 theta d theta. So what happened? What was wrong? Did I mess that one up on the video or something? Oh, okay. E to the 2 theta sine, not this one? Oh.
6.2.
Oh, 6.2. I'm sorry. Oh, that one had a tangent in it. Okay, so that probably, you probably didn't like that, did you? Okay, so it was cosine squared x tangent cubed. So I said on the test that there would be possibly a bonus, right? And I said that it would be most likely in the form of a reduction formula, right? If there was a bonus. This right here would be a candidate for what's on the test because we did talk about this last time. As long as it works out. I haven't worked it out yet. Let's see what happens. So the only thing we really know how to deal with at this point is sine and cosine. So maybe I should turn everything into sine and cosine first. This is cosine squared x. Tangent cubed is the same as what? Sine cubed x over cosine cubed x dx. Yeah? And we get some cosines to cancel there, don't we? Could cancel out, maybe. I would be left with what? One cosine on the bottom? So this would become integral sine cubed x over cosine x dx. It's a good problem. Now what? Did anyone get this, or anyone got stumped there? Okay, so here's a little reminder, some advice. Just because you are in Chapter 6, Section 2, does not necessarily mean you have to use the methods from Chapter 6, Section 2. So anything that you've done up to this point is fair game. So if you do that and you take a step back, U sub, what would you use as your U? Cosine? Because the derivative of that is negative sine and it appears up here, but you'd have to peel one off, wouldn't you? So let me peel one off first. Now I could make that U substitution. U is cosine x. The derivative of it is negative sine x, which is here. I'm off by a negative. But how are you going to deal with sine squared?
Oh, use that reduction. Or can you like
Can't do the... you might be able to do integration by parts, but we're trying U sub right now. Why not turn it into 1 minus cosine squared? Right? Wouldn't that just turn into then 1 minus... Remember what U is going to be here. Let's write that down. U is going to be cosine x, right? The derivative of that is negative sine x dx, which I can make it positive by just what? Changing that to a plus, changing that to a minus. So I'll be able to deal with that. But then sine squared, just so y'all are clear, you never square both sides here and say that sine squared dx, right, that whole thing squared is du squared. You don't mess with that. But I can get sine in terms of cosine using the Pythagorean identity. So if I rewrite this problem as what, integral this sine squared turns into 1 minus cosine squared, right, x over cosine x, and then sine x dx, right? That's where I am. Then at this point, making the substitution, this integral turns into, okay, 1 minus cosine squared turns into what? 1 minus u squared. And cosine on the bottom turns into u, and then sine x dx turns into negative du. So how about the minus out here and the du right there? And what can you do with that? You can just split it up, right? You have two terms on the top, one term on the bottom. You can split that into two integrals. So we'll have negative integral 1 over u minus u squared over u du, like that. Which is negative integral 1 over u minus u du. And these two can be integrated, right? Antiderivative of 1 over u, natural log of the absolute value of u, antiderivative of u, 1/2 u squared. So we'll have negative natural log absolute value of u, antiderivative of this, right? You have a negative, but then the negative again, right? So what, plus 1/2 u squared plus some constant. Understand? But what was u? Cosine x. So this should be my final answer. Should be negative natural log cosine x, and then plus 1/2 cosine squared x plus c. And this was number 13, so I doubt that's the way it appears in the back of the book.
No, that's the.
That is the way it appears? Okay. I thought for sure they were going to take this negative and bring it up as an exponent and then make that 1 over cosine and turn it into secant.
They had both the answers.
They had both? Okay.
Yeah, whether it's secant or.
Secant inside the natural log instead?
Positive.
Yeah, so that's one thing you could do. I'm just pointing this out. Is that the negative power would come up like a -1 and cosine to the -1. Not inverse cosine. Cosine raised to the -1 power is the same as 1 over cosine secant. So if you see this answer in the back of the book, that's where it's coming from. But that would be fine. That's it. So you don't need that technique necessarily. Now, it's not to say it couldn't be done. It might work, but this basic U sub worked just as well. And I think I alluded to this a while back. I said, you know, this first test is actually going to be relatively easy in the sense that we really only have power rule, basic substitution, integration by parts, and then a little bit of this trig stuff, which we didn't use here, but 6.2. So we really only have a little bit. There's still trig substitution, partial fraction decomposition. Those two are really tough. Yes?
Is each problem going to be labeled for which one to use it?
No. Integrals in general will always, I mean, like in an engineering class, if you come across an integral, it's not going to say use this method. So what we want to get good at is just looking at an integral and knowing, you know, we can attack it different ways without being prompted on how to use it or how to attack it. But that's what I'm saying. The good news is that we still only have a narrow focus on what we can use. The next test that we have, all the techniques will be on the table. And so there's really no, you just have to be really comfortable with all of the different methods. Yeah. Yes?
Could we take the non-review review home?
Oh, yeah, you can have this. Yes. This is really just a guide. It's just, I was just trying to get a layout of like what types of problems we had done. And I actually took these problems from my internet students who's supposed to be watching this video. And this is just, I took a bunch of problems out of their homework sets and came up with like a review. So, don't know. I don't know. I'll have to see. That's why I wanted you to work on this for the first half hour, 45 minutes, and then towards the end I can address any questions that you still might have on these. All right, are there any other problems you want me to do? Right now? I'll do more at the end when you've looked at this. Okay, let's go ahead and pass this out. Let's see. There we go. Go. Should be it. Okay, so remember, big asterisks here. I did not just hand you the review for the exam, right? Okay, I handed you some problems to take a look at. And so let's spend the next, wow, it's already 1:20. Let's spend the next half hour. Maybe we'll go till 2. Let's see how how it goes for you. And then I'll stop you at some point and I'll say, okay, who has a question over which one? All right? I do think that the length of this exam would be indicative of the length of your exam. I mean, I think it might be a little long. I would think maybe 20 problems tops. This is 24. So part of this is something I've also told you about. It's not just can you actually find, these antiderivatives, it's can you do them quickly. Does it take you half an hour to finally say, oh, that was just a basic U substitution, after you attacked it with all these other things like integration by parts and that only comes with practice. The more problems you've done, the quicker that is. And so that's part of what you're being tested on, is how fast you can get to these results. So work through these, help each other out, ask questions, raise your hand, I'll come by and kind of nudge you in the right direction. All right? I'm going to kill this video and then we'll bring back the second video later. So in order, around the class, and I will start this way, all right? Just because I'm left-handed and this is clockwise, that makes sense to me. So anyone at this table has a question, I'll start. Ivana, did you raise your hand?
Yeah, number 14.
14? All right. So is it something specific, or do you want me to just work the whole thing?
I think I can help you started on that one.
Okay. So, all right. So in this one, it tells you what the substitution is. Not necessarily something that would be given on a test. This is so u is equal to 1 over x to the 5th, right? They're telling you what substitution to make. And so you could rewrite that as x to the negative 5. And then the derivative of that is negative 5x to the negative 6 dx. Right? Do you have that anywhere? X to the 6th on the bottom, right? This is the same as secant squared 1 over x to the 5th times 1 over x to the 6th dx. That's what that really means if I peel it apart. Yes?
I was going to just push up to 6.
You could push that up also. It's
Then you
up to you.
what you need.
Yeah, you would have exactly this. So either way you look at it, this is also this, right? I mean, it depends on, do you want to use negative exponents or not? If you want to use negative exponents, you can use this. If you don't, you use this. So we almost have it, right? This right here, this right here. So we're just off by negative 5. So we'll scale out a negative 5. Negative 1/5 du equals 1 over x to the 6th dx, right? And I think we can just go straight in, right? Straight in. So this becomes integral secant squared of u, right? That was our u. And then this 1 over x to the 6th dx becomes negative 1/5, which I'll pull out, du. Good? Antiderivative of secant squared u is, that's, careful, tangent u, antiderivative. Right? Antiderivative of this is tangent u, but we still have the negative 1/5 out front. So negative 1/5 tan u, and then replace u with 1 over x to the 5th. We're done. If you ever want to watch an interesting video on YouTube, MIT, you all know MIT, Massachusetts Institute? They have an integration competition with their students, and they videotape it, and they basically put people up on boards, and they put up an integral, and then everyone goes after it. And it's a speed thing. It's who gets it the fastest. It's pretty amazing to watch. It is. Huh? I did the other couple of weeks ago. They put the problem up and I do it real quick. And some of them are really, really tough. Really, really tough.
Like, you can breathe, like, you have to actually, like, Tyler?
You know what? See, I teach at a certain speed because I don't, how do I say this? I have to communicate the idea across, right? This integral right here I probably could have done mentally pretty easily, but I'm not super fast at all integrals, right? And so these guys that are, and girls that are doing this competition, their brains just work super quick. I mean, it's crazy.
Students or teachers?
Students, yeah, yeah. I mean, for the most part, I kept up, but it was still. I mean, these are people that just love this stuff. Like it's like a spelling bee, right? If you're good at a spelling bee, does that mean that you're like a great? You can write great papers, right? If you're great at integrals really fast, that doesn't necessarily mean that you're going to be the best engineer. Okay, it's just you're really quick at that, right? It's not. It's just kind of neat to watch. That's all I'm saying. All right, how did I start talking about that? Thank you, Ivana, for the question. I'll move to the next table. Is that all right? Anyone there? Luke or Matthew? Yeah. Okay. Number 7. Yeah. So you know what? 7 did not really come across the way I wanted it to, because I just helped someone out with this, and when I created the problem, hyperbolic. When I created the problem using the software that made this, it didn't show me that second line where it gives you the sign and then the parentheses. I didn't see that when I created it, so I just thought they wanted you to prove this identity. That's all I thought they wanted you to do, is prove this. I didn't realize they were going to try and lead you through it.
No.
Okay? Is that what? Okay, so in your paper, the next thing, it says sine hyperbolic 2x equals sine hyperbolic parentheses x plus then blank, right? That's not what I would want you to do on the test, okay? This is what I would want you to do, and I would state it in here. Prove the identity using the definition of hyperbolic trig functions. What is the definition of sine hyperbolic x? What is its definition? E to the x minus e to the negative x over 2. That's the definition of hyperbolic sine. That's in your formula sheets, right? So if you replace this x with 2x, that gets replaced with 2x, and that gets replaced with 2x, right? So what we'd like to try and show is that this side over here is equal to this side, right? So which side do you want to start with? Do you remember me doing one of these way in the beginning? Yeah. Okay. Probably start with the right side. See what happens? And remember that what we want it to become is whatever this is when you plug in here. So why don't we just jot it down so we know what we're trying to get to. We're trying to get it to become this. Right? That's what we want the right-hand side to turn into. If we can turn that into that, we're done. Yes? Okay. So now, let's start with the right-hand side. So here we go. The right-hand side of this equation is 2 times sine hyperbolic x, e to the x minus e to the negative x over 2 times cosine hyperbolic x, which is same thing but plus between them, right? Over 2. Yeah? I can say at least one of these 2's cancel, right? This 2 that's still here, I can write that as a 1/2 out front. Agreed? This 2 on the bottom is like a 1/2 out in front? Yes? Yes? Okay. And now I can multiply these 2 together, and I can do like a FOIL. So let me try that out. What's e to the x times e to the x? E to the 2x. Well, that's good because look over here. E to the 2x. Right? So I'm going to have e to the 2x. Now, what about the next multiplication? Here to here? That's going to be e to the x times e to the negative x. You add the exponents. E to the 0 is 1. I remember doing that. You remember doing that? So that's 1 plus 1. And then what about this next multiplication right here? It's the same as this, right? But it's minus because it's a negative times a positive. So we'll have minus 1 here. And then what's the last multiplication? Minus e to the negative x, take away x, is negative 2x. The 1's cancel, right? Oh, I should put all this in parentheses. And isn't that exactly what we wanted? Yep. That is e to the 2x minus e to the negative 2x times a half, which is the same as this. So that is equal to the left-hand side. Check. Good question.
Yeah, I was just confused by the way.
Yeah, I know. I apologize about that. I didn't realize it until Kiki asked me. Okay, Paul, Chris, Ethan, Robert, Sean. Anyone back there have one? Or since your table has so many people, I'll let you ask two. Unless you don't have any, then we'll move on. All right, we'll come back to you. No? Ruben, anything?
About
16? They tell you what U is, right? On the test that you take on Thursday, I'm not going to ever tell you what U is, all right? I just don't want you to be surprised. Man, on the review, it always told me what U was, and then when he gave me the test, he never told me what U was. That's how it sounds to me when I read the reviews. So they tell you that U is cosine, right? But do you see why? Do you see why it would be? Why you would choose that? What's the derivative of cosine? Sine. So look, this is a basic substitution. You see something in its derivative. Why not pick sine for you? Why not pick sine? Because why? What's the derivative of that is cosine, but it's to the 10th power. You don't ever want the derivative of your u to be stuck and be more complicated than what you chose u to be. You don't want it to be trapped. You don't want it to be in a denominator. You don't want it to be under a root. You sure as heck don't want it to be raised to the 10th power. So u is cosine theta. du is negative sine theta d theta. We have that right here. We're off by a sign. I'll take care of that negative, change this to negative, that changes that to positive. And now the integral becomes u to the 10th. And then all this is just negative du, so negative goes on the outside. And that, we just use the power rule, right? So that becomes negative 1/11th u to the 11 plus c. And u is cosine. So I've had a few, yes, question?
Yeah. Can we do this using what we learned last class? Like cosine has doesn't need power?
Yes, but it also, sine is an odd power.
Oh,
Right.
Do they both have to be even or they both have to be odd?
No, what is the technique? Remember the technique from last class? There was 3 different techniques. Those were things that you could try. They never guaranteed that they were always going to work. But that one said if they were both even, then you try the power reducing. But if the sign was odd, right, then what does it say to do?
You separate it.
You factor out, right? But see, here you have only one factor of sign, so you couldn't separate out. You see what I'm saying? So I don't believe that would fall into last class. See, that's the type of problem that you get on a test, and you try and do what we did last class on this, and you spend 30 minutes going in circles, and then you realize, wait a minute, that was just a basic U substitution. So, all right, where are we at? Anything? Ernesto? Karen? You got anything? No? Which one? No? Which one? 9? Oh, yeah, remember 9? A telephone line hangs between 2 poles 14 meters apart. What is the shape of that called? Catenary. Catenary. So you have this wire hanging. They have 0, 7, -7. The wire hangs from 2 poles in the shape of a catenary. This is 5. They give you the actual equation of the catenary. This is it. 23 hyperbolic cosine x over 23 minus 18. That graph is this wire. And it says in part A, find the slope of the curve where it meets the right pole. Find the slope of the curve where it meets the right pole. So if we look at the pole here, do you all remember doing this one? Yeah, we did this, right? There's a tangent line that comes in here, and it meets somewhere right at that point, that tangent line. And so if we extend that tangent line out like this, we are looking for the slope of that line. That's part A. And then part B, it says find the angle between the line and the pole, which would be this angle, theta, the one between these two. Right? So how do we find the slope of that line? What's the slope of this line? That's the derivative, isn't it? So let's take the derivative here. The derivative of a hyperbolic cosine function is sine hyperbolic or hyperbolic sine function, right? The 23 just comes along for the ride because it's a constant out front. Sine hyperbolic, is it negative sine hyperbolic? No, for hyperbolics, the derivatives don't change signs. So this, and then we have the derivative of what's in here, what's in here, and then now the derivative of what's in here. What is the derivative of what's in here? 1 over 23. And then minus the derivative of 18, which is 0. Is everyone comfortable with the 1 over 23? Yes? That 1 over 23 and the 23 cancel. So all you're left with is sine hyperbolic x over 23. That's the derivative of the catenary, which represents the slope of the tangent line at any point on the curve. So now we want to know what's happening at that point, which means that our, what? Our x is 7. If we move out here to 7, we plug 7 into that, then we know the slope, don't we? So this slope will be equal to this derivative at 7, replacing the x here with 7, which is the sine hyperbolic or hyperbolic sine of 7 over 23. And how can you compute the hyperbolic sine? You can use your calculator, right? You could. Or you just do the e thing, but even then you need your calculator. So this will be equal to, how many of you have the hyperbolic sine function on your calculator? Everyone should. If you don't, it's okay. If not, it becomes 1/2 e to the 7 over 23. Is the sine hyperbolic plus or minus? Minus e to the negative 7 over 23. So whatever that is on your calculator. Anybody get that? 0.309? Okay. Just making sure you all agree. So we're getting that y prime. I erased my picture. Damn it. So y prime at 7 is 0.309. Now, how do we get theta? So, do you remember how we did this? Drawing this. Yep, we just drew a triangle, right? We drew a triangle from this picture. We know that to get from this point to this point, it has a rise over run. And we know that that rise over run is this number. So if I was clever and I picked the run to be 1 and the rise to be 0.309, then this line, this triangle would represent that slope, wouldn't it? Rise divided by run would be that number. And now how do you solve for theta in this problem? You know tangent of theta, right? Tangent of theta would be opposite over adjacent. So you have to turn your head this way. Opposite over adjacent. So you're going to do inverse tangent on both sides here. Theta will be inverse tangent of 1 over 0.309. And then make sure you know whether or not you're in degrees or radians. What are you in your calculator? Give it to me in degrees, please. 72.83 degrees? Good enough. What else? Anything else? Got about 7 minutes or so. All right, look, if you go onto our website, our Canvas site, I have a thing called files, right? And if you go in there, there's like old stuff. I do have a lot of older exams in there. The problem with these older exams is that a lot of those covered up all the way through Chapter 6, everything in Chapter 6. But there's stuff in here that has solutions in them. Okay, so like exams with solutions. So if you go look through the exam in the solutions, and you see a problem where I've got an integral, and then over here on the side you see that set up, then you know that required integration by parts. So maybe that was a problem that you can practice. Understand? But if it has a bunch of stuff that you've never seen us do, then I'd avoid it. Just showing you there's some places you can go to see other problems. But mainly for this test, what I want you to focus your attention on to prepare for it is your homework and the problems I did in class. All right? The homework problems and the problems that I lectured over. I have not made the test yet, so what I plan on doing is going through the homework sets, picking out problems, going through the class lecture videos, and picking out problems. But remember, all the videos I basically did, almost every single one of them, were based on notes that were handed out in class, right? Or that were in here in files. And they had examples that I worked. So if you just go back and look at the notes, look at the examples, you can work those on your own. Watch the lecture if you need to. All right? That's how I plan on building the test. Any questions? We good? All right, I've already taken attendance when I came by and checked everyone's homework. Please do not forget to bring your formula sheets, because if you don't have them, you don't have them. So I'm going to wrap things up here. I'm going to go down to my office, and I'm going to be in my office till 5 o'clock. If anyone wants to come by. Unless no one comes. If no one comes, I'm not going to hang out till 5 o'clock.
Are you gonna put an answer so we can just check after we're done?
How about this? If you have a question as to whether or not your answer is